right, this is a follow-up video to graphing exponential functions. You'll notice that I've got an exponential function up top here. We've got a 0.5 raised to the x. Now notice it has a few other things going on there. G of x there has a few other transformations involved, or some multiplying. We've got a negative in there. We've got some adding or subtracting. But the basic idea, right, is that we have a 0.5 raised to the x. And that's really how we want to approach transformations of functions. Again, we're going to graph this function using two easy points. But to find those easy points, I also want to find an easier equation to look at. So what I'm going to think about is g of x really has a parent function, f of x. There's a simpler function there. And f of x for me is going to very simply be just 0.5 to the x. I know that 0.5 to the x has a couple of easy points to find. I know that it also has a horizontal asymptote because it's exponential at y equals 0. And so if I want to find some easy points, right, and take advantage of that horizontal asymptote, and I'm actually going to make a third easy point. Now, it says two easy points, but just noticing that, again, this is exponential decay, sometimes it's easier to use a third point because normally I would always plug in 0 because 0.5 to the 0 is going to be 1. I would always plug in 1 because 0.5 to the first is itself. So it'll be very simply a 1/2. However, I don't love plotting fractions, and I know that exponential decay sort of falls from left to right, so I'm actually going to go a little bit farther to the left because 0.5 to the -1 is going to be a solid 2, right? It's the reciprocal of that half, the reciprocal there. So again, that just makes a third easy point to find. Now we'll get that horizontal asymptote on here. And now let's take advantage of why I talk about these easy points. Those 3 points were not hard to find when it comes to exponential functions. But now we need to adjust because remember there's this -3 out here and we also have this -2, right? F of x was the parent function, but g of x still has those things involved. So I'm going to start inside the function. I'm going to start with that -2. Remember that subtracting 2 inside the exponent, inside the function, is going to shift horizontally. Okay, we've talked about transformations before. Right 2 units. So I'm going to take all of my x coordinates and I'm going to shift to the right. So I'm taking -1, I'm going to add 2. I'm going to take 0 and add 2. And I'm going to take 1 and I'm going to add 2. I'm just going to add 2 units to each one of those numbers. Now, horizontal asymptote was y equals 0. Well, if you shift a horizontal line to the right, it's the same horizontal line, right? Imagine taking the y-axis and just sliding it to the right. Well, it's still the y-axis, right? It's still horizontal. So that's really not going to affect anything. But now what we do want to take a look at, though, is that -3 out in front. Remember that a negative multiplied in front is a vertical reflection. Okay. And a 3 multiplied out in front is a vertical stretch. If you remember your vertical transformations. And again, we're going to say by 3. So basically what we want to do is stretch the y coordinates times 3, but we may as well also multiply by that -1. So -2 times -3 will be -6. -1 times -3 is -3. And 1/2 times -3 is again a -1.5. So again, that's where those might get just a little bit messy there. But those points should all be very plottable points. So again, 1, -6 is going to be down here. 2, -3. And 3, -1.5. You notice they start to get a little messy there. And already I kind of have an idea what this function is doing. Again, I also need to transform my horizontal asymptote. If we multiply, again, the y coordinate, everything dealing with y deals with those 2 vertical changes, right? So we take that -3 and multiply it by 0, right? Well, the funny part is it's not going to go anywhere. Normally, if that was not a 0, right, if it was something else, if we multiplied, if maybe we added something to it, then we maybe move it up or down. And that's really what you want to watch out for. If we had a shift up or down, that would move that horizontal line, right? But for us right now, we're just going to go ahead and leave that right on the x-axis, right? We've got that horizontal line at y equals 0. I always like to label the horizontal asymptote there. Notice we reflected, so we're below the asymptote this time. Whereas our regular function, or our initial function, right, f of x, would have been something more like this blue point, right? These blue points that I'm plotting, we would have been up above here, right? That would have been f of x. Well, g of x, on the other hand, is down below the axis. Again, we're shifted to the right just a little bit. So again, we're kind of coasting out this way as far as that goes. Now remember that the domain is still all real numbers, right? We're still going from negative infinity to positive infinity. So basically we will pass the y-axis at some point, but again, we're not going to pass the x-axis. The x-axis is that horizontal asymptote. Let's try that one more time with a slightly different example, right? In fact, I'm going to back up back here. Let's try that with this example here. So if we're looking at f of x this time, so I better use a different name for the parent function, right? Maybe let's call it y. Its parent function would have just been 4 to the x. So let's get a few easy points here. So we're going to say 0, 1, right? 4 to the 0 would have been 1, and 4 to the first would have been 4. And again, the horizontal asymptote for any exponential, basic exponential function, right? 4 to the x is y equals 0. Now let's transform this thing here. We've got to multiply by 2. So that comes before addition, right? So we're going to say that that's a vertical. It's outside the function. Stretch, right, by 2. And then we're also going to add -3. So we're going to vertically shift, right? If you add -3, it's going to go down 3 units. Well, notice we didn't do anything up in the exponent. We didn't do anything horizontally. So those x coordinates can stay where they are, right? But again, we do need to move vertical stretch by 2. So I'm going to take 1 times 2 is 2, and move it down 3 units would be -1, right? And then the same thing goes, right? Oops, I have a bad fix on that parenthesis there. Same thing is going to go for my 4. Again, 4 stretched by 2. 4 times 2 would be 8. And then shifted down, right? So again, I'm taking this 4. I'm going to multiply it by 2. Makes 8. And then shift down 3 makes 5. So we get that 5 right there. And note, if you just plugged your 1 into your function here, that's exactly what you'd get. 4 to the first times 2 plus -3. We're going to get that 5 back. Now notice we also shifted on this one. Since we're shifted down 3 units, again, that horizontal line at y equals 0 is going to shift down to y equals -3. So let's get that horizontal asymptote on the graph right away. We're going to plot 0, -1, and 1, 5 on our graph. And notice, again, it's a vertical, or it's an exponential, growth function. So notice from left to right, we're going away from the asymptote through those 2 points, right? 4 to the x increasing quickly, and we get our graph. So again, that's transformations of exponential functions. It's a good way to kind of transform those graphs, right? An easy way to think of it. Grab a couple of easy points from the parent function, and let's move them, right? Doesn't take much to define an exponential curve, by the way. Once you know a couple of points, we know we're going away from the asymptote. That's about all we need for a basic exponential graph. For exponential decay, again, same idea. We just need a couple of points. We know we're going toward the asymptote. So again, we can draw that line fairly quickly and easily, right? Let's write out a couple of things just very quickly to finish this video off. The graph of f of x equals a to the x will be exponential growth when a is greater than 1. But it'll be decay if a is somewhere between 0 and 1. So when we're down here at the bottom and it says write a transformation, right, or transformed exponential growth function, well, I'm just going to sort of grab, they're not giving me a value, right? They're not giving me that base value for a. So I'm just going to say, well, hey, a could be 2 then. 2 is greater than 1, right? It's growth. And we want to make sure, again, that f of x then, let's call it that, is 2 to a power. But now notice we also want to make sure we have a horizontal asymptote at 7. We want to shift essentially up 7, right? Normally it's at 0. So if I want to shift up 7, I'm going to need to add 7. In fact, I'm going to do it right at the beginning. 7 plus, right? But then we also need a y-intercept at 8. Well, now wait a minute. If we shift up 7, our normal y-intercept is usually at 1, right? Well, hey, 1 shifted up 7 actually already gets me to 8. That means I don't really have to do a whole lot to make that happen. I'm thinking we should be able to just say 2 to the x, right? Although I got to be careful. Right? Let's make sure that actually works. Let's plug 0 in. 2 to the 0 would have been 1, plus 7 would have been 8. And again, horizontal asymptote just comes down to that vertical shift. So I think we're in good shape there. Again, maybe you got a different answer just because you used a different number than 2. But other than that, that should kind of hold steady there. What about if we wanted to transform an exponential decay function? Well, to be decay, now I need an a value that's going to be less than 1, right? So let's just call it a half. Horizontal, again, asymptote at -5. So really, if I'm going to write a function here, I'm going to go ahead and shift down 5 right away. And again, a y-intercept at -3. Y-intercept of -3. Well, again, it's normally at 0, 1. Right? Normally at 0, 1. But we're shifted down 5. So I should be down at -4. Right? Down at -4. Which just means that what I really want to think about is maybe instead of shifting down from 1 down to -3, maybe I can shift, right? Maybe from 2, right? That would be 5 units down. 2 minus 5 is -3. So maybe we should double our graph, right? Maybe we should stretch our graph. If I stretch this, now 0 would have been 1 times 2 is 2, plus -5 would be -3, and I think we're in good shape there. I think that's some pretty good reasoning going on. And then finally, notice at the bottom, how about a natural exponential function, right? Well, immediately I'm thinking that means we've got e to a power. We've got to say e to the power. Horizontal asymptote at 4. Well, I better shift up 4 units. And again, a y-intercept of 1, 0, 1. Well, now normally it's at 0, 1, but I'm already shifted up 4 units. And if I'm going to be below the asymptote, I'm already thinking, well, that better be a negative, right? I better vertically reflect, right? So let's go ahead and erase here real quick. I'm going to go ahead and say, how about 4 minus e to a power, right? And in that same way, again, thinking about that graph, normally we're at 0, 1. I'm already going to be reflected down to -1. But now I need to be up at 1 again. I need to be 2 units higher, right? I need to be 2 units higher than that. Well, we've already shifted up 4, right? Again, the asymptote's already up here at 4. So if I'm going to shift up 2 units, right? How about we try that 2? How about we multiply by 2 again? 0, e to the 0 would have been 1. Times 2 is 2. 4 minus 2 is 2. Oh, I don't want to go quite as high as that, right? So I've got to do a little bit of work to make this work out here. What if we multiplied by 3 instead? Would that work for us? Right? Force ourselves to be a little higher. E to the 0 is 1. 3 times 1 is 3. 4 minus 3 would be 1. I'm thinking we're in good shape there. Again, you can check my work on that one. But again, just talking about transformations of functions, think about how we can move our functions around, right? How we can reflect them, stretch them, and shrink them. If you have any questions, talk to your teacher, and have a great day.